Our next speaker for the day is Mr. Karen Dias. He's in BCom MBA and he's an industry expert in personal protective equipment and occupational hazard protection. Though he comes from a very different background, he, by virtue of his work line, has taken and his passion towards this field, is keenly and deeply interested in this line of personal protection, both in the industrial sector and now, since the time of COVID, in the health sector as well. He's an entrepreneur. He's a business management and operations planning guy. He's got special interest in PPE and occupational hazard protection. And he's the recipient of various regional and national awards for management of key accounts, business units in personal safety division. He, you'll be happy to know, has been instrumental in training the staff for donning, doffing, or what is the meaning of PPE and the various aspects of PPE at the ESI COVID Hospital Margao, Hospital, and various other hospitals as well. I'll now hand over the mic to Mr. Dias, and I thank him on behalf of IMA Tiswadi and IMA Goa State for having accepted our invitation and to enlighten us on these technical aspects of PPE, which are not a part of our medical education. We are lacking knowledge, or we have patchy knowledge of this. We expect to clear this from Mr. Karen. I welcome you.
Hello. Hello.
Yes, Karen, we can hear you.
Yeah. Should I share the screen, doctor?
Yeah, you can start sharing your presentation.
Is it audible?
Yes, you're clear. You are clear. We can see you. We can hear you. Can members hear? They can just type. Yeah. Now you can begin your lecture, Karen.
Okay. So first of all, good evening, everyone. My name is Karen Dias, and I would like to thank Dr. Afzal and the IMA Tiswadi for giving me this opportunity to introduce you all to PPs, or rather, simplify the jargon of PPs. I would I'm not a medical expert, but I can tell you from point of view of a PPs how to use what are the PPs and how to make the most of the PPs, how to optimize PPs. Uh, uh, Hello.
Yes.
Okay.
Yeah, we can hear you.
So, can I start, doctor?
Yes. We can hear you. You go on.
Okay. Yeah. So what are the different types of PPs and what is PP in the first place? Okay, PP in the first place is basically any device which is designed to protect a worker from occupational hazard. Now, as you know, occupational hazard, what is occupational hazard? Occupational hazard is nothing but hazard or risk associated with one's respective occupation. Okay, so from a medical point of view, what would be your hazard? Something like uh, inhaling airborne particles or different other having a splash into your eyes, different hazards associated with your respective function or job. What are the different types of PPEs now? We have head protection, eye protection, PPEs for face, hands, feet, body, hearing, and respiratory. But for today's presentation, I would mainly be concentrating on respiratory, followed by a brush up through body and face protection. Okay. So now this is one of the most commonly faced dilemmas in the safety industry, and that is a safety officer or people would always be uh, they would reach to a Y junction or a cross point as to do I go with engineering controls or do I go with respirator? Any problem that is looked at, do I choose the PPs or do I choose engineering controls? Well, from how do you look at the problem is when you look at hierarchy of controls, you first always remember you first look at eliminating the problem. Then you can, if you're trying, you can try to substitute the hazards. If not, then comes your engineering controls, administrative controls, and PPs. Basically, PPs is always your last line of defense. We repeatedly say never treat PPs as your first line of defense. Now, from a medical point of view, what would be engineering controls? Again, assuming you're working in an area where there is a patient, so your engineering controls would be something like your high vac system, your air handling units, stuff which you would be able to, assuming there is a splash or assuming there is a cough or something which is in the air, your exhaust or your air handling units would first take care of the exposure. Second thing is you have administrative controls. Now, administrative controls is something basically where you say you keep 1 meter distance, or you probably would say if I'm meeting say 20 people in a day, I would probably reduce that to 4 or 10 people a day. So you're trying to reduce your the amount of exposure that you are to. And then the last line of defense is PPs. So basically, PPs is in case your engineering and your administrative control fail, you still have your PPs in place to protect you. Hello?
Yes, Karen, go on.
Yeah, okay. This is just a pictorial diagram of how engineering and administrative control work. As you have seen, people are working here. They are using the PPs, but you can also see the high-rate system, the air purifiers. We have the exhaust that is working. Also, administrative controls, as in they are limiting the number of people in the workplace. Also, they're keeping a probably safe distance. So they're all trying to make sure their exposure is reduced. And finally, they also are wearing, as you can see, respirator and a reusable full face piece.
Karen, I'm sorry to interrupt you. Just it could be a little bit slow. Sorry to interrupt. A little slower because the voice there's a little reverberation. So just go a little slow.
Okay. Hello.
Yes, you can go on.
Yeah. Okay. Okay. Doctor, is this okay?
Yes, this is fine. Go on.
Okay. So now, when I come to respiratory protection, before we dwell into respiratory protection, I'd like to explain certain concepts and fundamentals of respiratory protection first. Okay. So first of all, understand all respiratory protective devices are intended basically just to reduce the exposure level to a permissible exposure limit. No respiratory protection device will always give you 100% protection. Okay. Now, when we come to different types of filtration with respect to particulate filtration, these are two types of particulate filtration that is there. One is mechanical filtration and one is electrostatic force of attraction. Now, as you can see, a mechanical filtration is nothing but you have a web. Okay, it's like having a web. Things which are bigger in size would get trapped, but there are things which are smaller in size, probably size less than 100 micron, less than 15 microns, which would easily pass through. For example, you have a big fly. Just for example, you have a big fly that is getting trapped, but you also have a small fly that would pass through. Now, coming on to electrostatic force of attraction, in this particular type of filtration, we have the fibers of the filter media are electrostatically charged, and basically each fiber has been given a charge. So irrespective, as we all know, every particle in or everything in this around us or in this universe has a charge. So irrespective of the size of the particle, when anything passes through these fibers, because of the charge, they will get attracted. And that is the reason in electrostatic force of attraction, even with a very thin filter media, you are able to achieve a very high level of filtration as compared to mechanical filtration. Now, the same level of filtration can be achieved through mechanical filtration also, but for that you'd have to increase the layers of webs, okay, or the layers of the filter media to achieve a desired level of filtration. But the problem with that is, with that, your breathing resistance will also increase. Uh, Now, as these are certain fundamentals of filtration mechanism, the basic idea of filtration mechanism is basically bringing particles which are suspended in the air in contact with the fibers of the filter, with the fibers of the filter, or basically bringing them in contact with the filter media. Okay. Therefore, hello,
Yeah, hello, Karen. Yeah,
hello.
yeah. Can you hear me?
Yes, Doctor, am
Yeah,
I
just
audible?
yeah, you're audible. Just there's some reverberation. Is there any mobile device near you? I have kept my mobile devices away. If there's any mobile device, you could just move it a little away. I think it'll become much more clearer.
No, it's out. It's out.
Okay, yeah, yeah. You may continue now. We can hear you. Thank you.
Okay. So again, so basically filtration is nothing but bringing the particles suspended in the air in contact with the fibers of the filter. Now, before I proceed, okay, it is important to understand that pathogens like bacteria and viruses do not roam as so-called naked microsomes in the atmosphere. When brought in, they collide or they will attach themselves to bigger particles in the form of sputum or other secretions. Now, therefore, if we need to filter these bacteria or viruses, we focus on these bigger particles. Therefore, by focusing on the bigger particles, it is a misconception to believe that it is difficult to filter out viruses as compared to bacteria because they are smaller in sizes. So based on this, we then further categorize different size particles into three different categories. One which is less than zero point 0.1 micron, one which is between zero point 0.1 micron and 1 micron, and one which is above 1 micron. Now, the size of particles which are lesser than 0.1 micron, which we call as sub-micron size, the particles, when moving along with the airstream, they continuously collide with the air molecules, thus not only constantly seeking escape, but they also gain traction. And in literature, we call these movements as Brownian movements, and it is because of these movements, the Brownian movements, that they ensure that they do not go away or they are caught by the fibers of the filter media. Now coming to the category where you have zero point 0.1 micron to 1 micron. Well, this size of particles are the most difficult to filter because they normally bend along with the airstream. You will often hear people saying, attendants being said at zero point 0.3 micron, using the word zero point 0.3 micron. Why 0.3 micron? Because in this particular range, at 0.2 micron, the penetrating property of a particle is at its peak. Okay, so as you can see here, hello, hello.
Yes, Karen, go on. Go on. I'm just muting myself so that the voice is clear.
Okay, so hello, yeah. So basically, in this kind of at this kind of particle range, when a particle passes by, it tends to deflect along with the air, as you can see under interception. Now, most of the respiratory protective devices, the fibers of the filter media have been given a charge. It is because of these charge that the particles, when moving along with the airstream, are attracted or intercepted. And this kind of a filtering mechanism is called interception mechanism. This is one of the main reasons respiratory protective devices which have electrostatic media have expiration date, because in time eventually the the charge dissipates, and even if the respirator gets wet, the charge tends to dissipate, and therefore we always have expiration date for these kind of protective devices. Next comes for the category of 1 micron and above. Well, in this size of the micron, the filter media. Hello, hello,
Yes, Karen. Karen, you go on. We can hear you clearly. You go on.
doctor, am I audible to you?
Yes, you're audible to all. I'm just turning my mic off so that there is no echo. You go on. Okay.
Okay. So when it comes to the size of particles from 1 micron and above, what happens in these particles is, because of the mass in the particle, they tend to deviate less with the airstream, and therefore they come in, when projected out, they come in direct contact with the filter media, and therefore we call this kind of a filtration mechanism as, hello, hello.
Yes, Karen, go on.
So we call this kind of a filtration mechanism as initial impact mechanism. Okay, so now coming to a surgical mask and a respirator. Now, first of all, just to make things clear, we call the one in blue, we call that a surgical mask, and we call this a surgical respirator, or we call it a disposable respirator. The main difference between the two products are basically surgical masks are meant or worn to prevent product or person contamination. Like a person would wear it, a doctor would be wearing it so that when he's operating, his saliva or his facial hair don't come in contact with the patient. Or when you're working in certain industries, we wear a surgical mask so that we don't contaminate the product. Whereas a respirator will do both. They will basically prevent product or person contamination. At the same time, they will offer a person also protection. Now this mainly happens because of two main reasons. One is because of the filter media, and second because of the fit factor, which I will be covering up in the next slides. Speaking about surgical face masks, as per EN 14683, we have 5 types of parameters which are used to determine the efficiency of a surgical face mask. One we have is, often you will see as PFE, which is known as the particulate filtration efficiency, then which basically just certifies the quality of the filter media. We have the bacterial filtering efficiency, which basically certifies how much it can withstand in case there's a splash of blood. To protect basically the filtration of synthetic blood, we have fluid resistance, which basically prevents, again, the ability to prevent or have a barrier to allow fluid to penetrate. We have differential pressure, which relates to breathing resistance, and we have flame resistance. Now, if you can see, in none of these parameters do they actually test the protection factor which is offered by the surgical face mask. That is the reason a surgical face mask is never able to offer us a protection. Rather, it protects from person or product contamination. Now, you will ask me, how is it so effective in preventing or protecting the product or a person contamination? When a person normally exhales, hello.
Go on. Karen, go on. You are clear. Just go on.
Yeah, when a person normally exhales, the size of the particles which are exhaled are between 4 to 8 micron. If you go back to my slide, at 4 to 8 micron, we have the initial impact mechanism which is active, and therefore when the air deflects to the filter media, the air deflects and goes, leaving the particles caught with the fiber. Now we have different names known all across the globe for surgical face mask. You have triple layer face mask, you have 3-ply face mask, you have surgical mask, procedure mask, but they all relate to the same product. Now, before I get in depth with a respirator, there are two very important components of a respirator, or for the efficiency of a respirator, it is important. One thing is how good your respirator is, which relates to the efficiency of the respirator. And the second thing, it refers to the seal, how good fit factor. You need to have a balance between both these factors. No matter how good your respirator is, but if you don't get a proper fit, you're not adequately protected. And no matter how good your fit factor is, if your respirator is not good enough, you're also not protected. So at any point of time, to get a desired level of protection, you need to have a good fit factor and you need to have a good efficient respirator. So coming next, we have broadly, these are the types of respirators available, but we have broadly two classes of respirators. One we have is the air purifying respirators, and the other class is the air supplying respirators. Now, air purifying respirators are that class of respirators, assuming I'm working in an area, they will filter the air in which I'm working and I will be getting the filtered air. Air supplying belongs to those class of respirators where it is not possible to filter the air in which we are working, and therefore we basically breathe from external sources of air. Now, for example, let me give you examples of air supplying respirator. Have you seen a fire brigade personnel or emergency response team, whenever there is a house or anything caught set in fire and they go in with this ABA self breathing apparatuses, they walk in. Basically what they're breathing is from the cylinder. They're not filtering the air within. That is basically because it is not possible, or they do not know what is the concentration of hazardous substance in that area. Hello.
Go on. Karen, go on. We can hear you.
Doctor, I keep getting in. Okay. The next we have is the airline system, which basically is a filter panel which is normally set up on a wall, which basically is connected to a compressed airline system, and the filter panel is then connected with a hose, and the hose is then connected to a respiratory protection device which a person wears, in which he is basically breathing air from external sources. Now these all come under the air supplying class of respirators. Now coming to the air purifying respirators. Under air purifying respirators, we have something called as a disposable respirator, which you can see here as N95. We have the reusable half face piece, we have the full face piece, and we have the PAPR. Now, we call the first type of mask, you would often hear this as a disposable mask or quarter mask or disposable respirator. The reason we call this kind of respirators as disposable respirators is because once they are choked, or once the filter medias are choked, we discard it. We cannot reuse it. But the main question is, when do you discard it? How do you know you have to discard it? So the rule of thumb in this kind of class of respirators is basically, as long as you can breathe normally, generally speaking, as long as you can breathe normally, you're good to use the respirator. Now, the moment you feel choked, or you feel you have to use extra force to pull in the air, or there's a physical damage to the product, or the product is significantly soiled, you have to discard it. Now, certain companies, certain industries, they have their own SOPs for discarding respirators. For example, in the pharmaceutical industry, after every shift, whether the respirator can still be used or not, they ask, or the SOP is that they need to discard the respirator because of product contamination. In certain industries, like in the healthcare industries or certain industries, because the respirator has been significantly exposed to airborne particles or it has been soiled, you discard it. But generally speaking, as long as you can breathe normally, your disposable respirator is good to use. They are also called as maintenance free respirators. Now coming to the reusable and the full face piece. The reusable respirators are also called as low maintenance respirators because they can be reused once the filter medias are choked. They can, all you have to do is basically replace the filters or the cartridges, but you can reuse the half face piece, or you can reuse your full face piece. Now, if you use a half face piece, you probably need to use a goggle. If you use a full face piece, you need not go in for an eye protection. Now, if you can see, the disposable, the half face and the full face, they all come under the negative pressure, mainly because you're pulling in air, and we normally use, and in these kind of respirators, we use our lungs to basically pull in the air. Now coming to the PAPR, the PAPR mainly is a powered air purifying respirator, which basically constantly supplies air in a positive pressure, and therefore the rate of air supplied is constantly high, and therefore there's no provision, or there's no chance for the air to come in because of the high supply rate of the air which is pumped in. Now it is very important for you all, because we are in the medical industry, it is very important to understand that apart from the disposable respirator or the quarter mask, the half face piece, the full face piece, and the PAPR all above, they all have exhalation valves, which is why as these respirators are not recommended in the healthcare industry, because mainly because it can be a threat to the safety of the other person. Hello.
Yes, Karen. Yes, we can hear you. Go on. It's going on well.
Doctor, am I audible? Because I keep getting it just goes blank.
No, no. What's happening is you're not visible, so that's no problem. But we are here listening. We can hear you very clearly. So you continue without any problem. Just continue.
Okay, okay. So coming back to this point now, in the disposable respirator, mostly disposable respirators offer you particulate protection, and they will not offer you protection against gases and vapors. In case you need protection from gases and vapors, we basically opt for a reusable respirator. We opt for a reusable respirator with an option to either have particulate protection or a combination of vapors, gases, and particulate protection. Also, understand one thing is in the hierarchy when you have the disposable respirators, the half face, the full face, the PAPR, the protection factor significantly increases. That is mainly because the protection factor of the filter media increases. Also, what is very important is you considerably get a better fit. Now what happens is in a disposable respirator, even if you wear it in an appropriate manner in which it is supposed to be worn, you might or you might not get a close to 100% protection or 100% fit, which is why which is why we one of the most commonly faced issues when you wear a disposable respirator and a goggle, your goggle will start fogging. That is mainly because you're not getting an appropriate fit. Whereas when you move to the reusable respiratory segments, you get a better fit, you get a higher protection factor. But since again respirators with valves are not recommended in the medical industry, I will not be mainly dwelling on the reusable respiratory segments, but can be discussed on case to case basis. Now as you can see here, the main difference between a respirator with a valve and without a valve, uh, a respirator with a valve is basically a one-way protection wherein it protects the wearer, but because the exhaled air is not filtered, it can be a threat to the safety of the other person. Whereas a respirator without the valve is a two-way protection. On the other hand, a respirator with a valve is more comfortable, mainly because when you exhale, it immediately throws the hot air out, keeping the inner area cooler. When the inner area is cooler, a person will start less fidgeting with his respirator, or he will not sweat. What happens is one of the main disadvantages faced in a disposable respirator is because the inner area is trapped, you tend to sweat for a longer period of time. Also what happens is the amount of carbon dioxide you keep breathing in increases. Hello. Which over a period of time might lead to fatigueness or different other issues. But again, we as we say in the healthcare industry, we don't have an option but to make the best, or to make sure that we wear the disposable respirator without the valve in a most appropriate manner to get a desirable level of protection. Now, coming back, a general question that we all normally face is they normally ask is how do you choose, between when to wear a disposable respirator, when do we wear a half face, full face, or a PAPR. So basically there are, when deciding what class of respirators to wear, we come across two main terms. One is an assigned protection factor, and second is a hazard ratio. Now if you can see, in simple, what an assigned protection factor is, basically it is the level of protection with which each class of respirator is designed to provide. For example, if you can see 5, which basically means a cotton mask has an assigned protection factor of 5, which basically means the concentration of the contaminants around you will be, hello, is reduced by 5 times. For example, if we were just to give an example, if there are 100 particles suspended in the air, when you wear a water mask appropriately, the concentration will be reduced by 5 times. Now this is as per standards. So as you can see, the assigned protection factor for a disposable respirator or a water mask is 5, for a half face mask is 10, for a full face is 50, and a PAPR when you use it with a half face mask is 50, when you use it with a hood is 1000, and loose fit fitting face space is 25. Now this is part 1. Part 2 is a hazard ratio. What is a hazard ratio? Hazard ratio normally in the industry is what we say, there's a hazard ratio which we calculate as the concentration of a chemical in the atmosphere where we are working divided by the OEL of that particular chemical. Okay. Now the OEL basically means is occupational exposure limit. So the OEL of every chemical will be fixed throughout, whereas the concentration will vary. Probably I'm working in an area, just for example, I might be working in an area where the concentration of chemical might be 0.5%. There might be someone who's working in an area where the concentration of the chemical is probably 10, 12, or 48%, just for example. So how do we select a respirator? Is, let's just take an example. Normally we have isopropyl alcohol. Just for example, if the concentration is around 800 ppm and the OEL or the occupational exposure limit or the TLV for this particular chemical is at 200 ppm. So when you divide this, we get 4. Now, when you take this 4 and you go back to this slide, you will see that 4 a quarter mask basically is an appropriate or can be an appropriate type of a respirator for this kind of a product, or when requiring protection against this kind of a chemical. Okay, now I'll come to mainly two main standards which we often see in the industry, which most of the disposable respirators are certified. One is you have the NIOSH N95 standards, and you have the EN approved respirators. Now NIOSH is again a National Institute of Safety and Health, which is nothing but a American certified agency, whereas you have the European approved respirators, which conforms to the European standards. Now, their testing parameters for the disposable respirator is NIOSH basically, as for the NIOSH protocols, you basically test just the filter efficiency. And for this filtering efficiency, they use a particle size of 0.3 micron. Whereas in the EN standards, they normally look at it from a total inward leakage, which is subdivided into 3 parts, which test the filtering efficiency, which tests the efficiency of the fit factor between the respiratory protection device and the wearer's fit, and the performance of an existing valve, if any. The size of the particles that the EN 149 standard uses is between 0.2 to 2 micron with a medium of 6 micron, with a medium of 0.6 micron. Based on these standards, we have standards which are derived, which are NIOSH N95 and EN 149 for the disposable respirators. Now, we the NIOSH standard subdivides it into 9 categories, which is N, R, and P. N referring to not resistant to oil, R referring to resistant to oil, and P referring to oil proof. So we have N95, which basically means 95% filtering efficiency at 0.3 micron. Likewise, N100 will be 99.97% efficiency at 0.3 micron. Likewise, you have R95, R99, R100, P99, P100, P95. So basically, P95 would offer you 95% efficiency, P99 would offer you 99% efficiency, and P100 would offer you 99.97% efficiency. Coming now to the EN approved respirators, they divide it into majorly 3 categories: P1, P2, P3. Often you will find as FFP1, FFP2, FFP3. Basically, what this means is filtering phase piece 1, filtering phase piece 2, filtering phase piece 3. P1 offers you a protect efficiency of 80%, P2 offers you an efficiency of 94%, and P3 offers you an efficiency of 99.95% with a total inward leakage of not greater than 2%. Now, although the testing parameters are different, but in literature, we consider P2 as an equivalent of N95. Often you will also see CDC recommending in case N95 respirators are not available, or as a substitute or as an equivalent, you can opt for the P2 or P3 respirators, provided it is more applicable in your industry as if they are not one. Now, one of the most commonly faced issues during this pandemic is we have seen globally, not only in India, I would say globally, basically there are a lot of counterfeit products. And one of the major challenges as I go back is understanding whether your respirator is good or no, right? As you can see among this, one is the seal of the respirator and the second is how good your respirator is. So coming back to this slide, as you can see, any NIOSH N95 respirator will have the following components. One is a brand. It will have whether it can be any XYZ, like you, one of the most commonly known brands are 3M, Honeywell, Venus, Joseph Leslie Co. We have different types of brands available. We have the brand, we have the model number, we have the N95 mark, and most importantly, we have the test certificate number, which starts with 84A and it will have another 4 digits. If NIOSH, I've also shared the link down. If you, CDC has also published a list of NIOSH N95 approved manufacturers list, which basically states who are globally who are the approved manufacturers of N95 respirators. And I'm very sure right now a lot of you would be wearing N95 respirators. So a quick way of checking whether what you're wearing is a counterfeit product or no is you can just check it. If it has the following details, more particularly, it should have a test certificate number which starts with 84A and it will have the following phone numbers. If it is there, it is a genuine product. Of course, you can check it on the website as well. If it is not there, you're most probably wearing a counterfeit product or you are wearing a counterfeit product. Coming to the EN approved respirator, you will have again the brand, the model number, you'll have the CE mark, and you'll have the class, which basically certifies whether it's P1, P2, P3, and you'll have a 4-digit identification number. Now, just for your reference, I have attached images of EN approved respirators. As you can see, it has the brand 3M, it has the model number, which is 9332A, it has the standard, and it has the respiratory class of FFP3. Hello, doctor?
Yes, yes, I can hear you.
Yeah, okay. Coming on to Venus, as you can see, we have the brand, we have EN149, we have the class of FFP2, and we have the 4-digit identification number as well. Now, these are EN approved respirators. Now, coming on to the NIOSH approved respirators. As you can see here, we have Venus, we have 3M. Most importantly, can you see the 84A and the 4-digit number? That basically is a quick way of telling whether your product is a genuine product or no. The same number, like for example, when we see under Venus V4400 N95 NIOSH, we do see the test certificate 84A8126. Now, if you go under this website, you will see under the brand name of Venus, you will see this number, which is basically a number or it's a test certificate number, which is given particularly to this particular model and brand of respirator. Now, just to give you a demonstration, I would like, because one of the most commonly seen things are people not wearing the, see, I keep telling people is there is no point in wearing a respirator if you're not going to wear it appropriately. Hello?
Yes, yes, we can hear you.
Yeah, doctor, how can you see me? Because I want to perform the test.
We are not able to see you because of some net issues, but we are able to hear you clearly.
Okay. Doctor, just let me know when you can see me so that I can show you a live demo, but I will try to explain in the best possible manner. Okay.
What you could try is just switching off your camera and switching it on again.
Can you see me now?
No, I think there are some net issues. We are only seeing your name and we are able to hear you clearly, but we are not able to see you. So I would recommend whatever you can cover or orally you cover that if you cannot demonstrate.
Okay. What I'll do, doctor, is I will cover it orally in the best possible manner I can.
Sure.
In the event the lagging is issued, I mean the lagging problem is solved, then I will perform a live demo and show you how to wear it. Okay.
Sure. Okay. Yeah. Thank you.
Can you see my presentation now?
Yes, we can see your presentation. You can make it full. Yeah.
Okay.
Thank you. Thank you.
When you hold a respirator, always spot first. The first thing about a respirator is you have to visually observe the respirator or visually inspect the respirator for any physical damage. Again, In case the respirator is physically damaged, you cannot use the respirator, or it is inappropriate, as it will not give you a proper fit. The second thing is you have to see where is the nose clip. The nose clip is now something often we find people wearing the respirator upside down. So the nose clip basically goes, it is meant to basically be on your nose. The top strap basically goes on your crown, and the bottom strap goes below your ears. Once you do that, you make sure the straps are well adjusted, and based on that, then you make sure that your respirator is fitting you appropriately. Once that is done, you can perform a basic fit check by placing your hands gently upon the respirator and exhale sharply. When you exhale sharply, in case your respirator bulges, you are having a appropriate fit. And when you inhale sharply, when you inhale sharply when you inhale sharply, in case your respirator collapses or you feel it collapses, then you basically have to understand that you're getting an appropriate fit. When you exhale sharply, in case your respirator does not bulge, it is an indication that basically the air is leaking. Or when you inhale, in case it does not collapse, your respirator is leaking from some way or the other. Now, just to give you an indication, a very important factor is facial hair will disturb the fit of a respirator, which is why we normally recommend clean shaved, so that the facial hair does not come across the fit protection of the factor. Facial hair does not allow a respirator to properly seal itself. Okay. Now, this is just an example of how.
I'm sorry to disturb you. Sorry to interrupt you.
Yes.
Yeah. Many members are able to see you, and though I am not able to see you, I just asked. Many members are able to see you. So what they're saying is, you could go ahead and give a demo or show us how you did it.
I cannot see anyone. I can only see my screen. But can you see me this way? Can you ask your members? Is it possible to see? Is it? Am I?
Yeah. So if you stop sharing, if you stop sharing your PPT temporarily,
Okay.
and put your camera on, and yes, now if you could demonstrate, that will be good.
Now am I audible? I mean, now can you
Yes,
see me?
you're audible and you're visible. You can go ahead,
Okay, doctor,
demonstrate.
I'll have to take off this earphones, okay, because I don't know if you'll be able to see me. But I will take off these earphones while performing this the demonstration.
Sure.
Okay, yeah. So this. Hello,
Yeah, go on, Karen.
doctor, am I audible to you?
Yes, you're audible. You can go on.
Okay. So this is the respirator that I'm holding. It's a non-valve respirator. As you can see, this is the nose clip of the respirator, and these are the straps of the respirator. So the first thing that you normally do is a visual inspection of the respirator. You have to probably check for damages or physical aspects of the respirator. If that is fine, hold your respirator. I'll just try to make sure I am in the best possible manner. If you can hold your respirator this way, this is your nose clip. You're holding the respirator this way. The top part of your strap, the top part of the respirator, the top part of your respirator, the top strap of your respirator goes above your crown, and the bottom strap of the respirator is below your ears. Okay. Once this is done, make sure that you get the straps adjusted appropriately. Make sure there are no folds. Okay. Likewise for the bottom strap. Once this is done, then make sure your respirator is fitting you appropriately. Often we find respirators folded this way. Often we find respirators which are folded this way. They're not giving a proper respirators. People wear respirators which are bent make sure all that is appropriate. Then make sure with two fingers you press the nostril. Hello, can you hear me?
Yeah, Karen, is your camera on, Karen?
Yes, my camera is on, doctor.
Yeah, some people can see you. You complete it, then we'll go on. Just finish it off. Not all can see you, but some members can see you.
Yeah. So basically, once you do this to perform a small fit check, we normally place our hands on the respirator. We normally place our hands on the respirator and exhale sharply. In case you feel the respirator bulges, means you're getting an appropriate fit. In when you inhale sharply, in case your respirator collapses, it's also these are indications basically that you're getting appropriate fit. Now, one of the most commonly faced issues is we normally find people wearing their, as in they interchange the straps. The top will go down and the bottom will come on top. Now, please make sure you don't just do this because when you the respirator is designed in such a way that the top strap has to go on top and the bottom strap has to go down. Unless you do that, unless you hold the respirator appropriately, there is no enough tension or basically push the respirator to get proper. Hello.
Yeah. I think there are some connectivity issues, so members are not able to see you. Most members are not able to see you. So I think you can, means once you wrap it up, get back to your PowerPoint presentation because we are nearing our time limit also.
Okay. Do I go ahead with the presentation?
Yeah, you can go ahead with the presentation. Yeah. And you could just turn your mic off and on again.
Okay. Am I audible now, doctor?
Yes, you are. You're.
Am I audible now?
Yes, you're audible. Go on.
Okay. Okay. So never leave the inner part. Always make sure, no matter how soiled the outer part of your respirator is, but never make sure that your inner part of your respirator is not soiled or not contaminated, because once you wear it, you are straight away going to breathe it. It is also important with respect to a wear time. It is also important that you make sure you wear your respirator throughout the time you are in the area in which you are seeking protection. Taking off your respirator even for 10% can have a significant impact on the protection factor offered by your respirators. Doctor, there?
Go on. Go
Yeah,
on.
okay. Now coming to the N95 respirator reuse strategies. Before we get on to this, hello? Okay,
Go on.
yeah. Okay, now before we get on to this, it is important to understand a few terminologies which are normally considered when during the reuse strategies. One is extended use. Extended use basically means you wearing the respirator without taking it out for an extended period of time. Reuse refers to basically taking off and wearing your respirators after each encounter, and limited reuse is basically limiting the number of times you reuse your respirator. Now, it is very important that some manufacturers of N95 respirators will strictly mention saying that it is a single use respirator, or they will mention that number of times it can be reused. Now, CDC recommends, in case this option is not made available by the manufacturer, you should not use it for more than 5 uses per respirator, to make sure that you have, or make sure that the functionality or the safety margin provided to the user is maintained. Some of the most commonly followed strategies, because of shortages of respirators all across our respirator rotation, what people are doing is they have sets of 5 respirators, which probably they assuming they have respirator A, numbering respirator A, B, C, D. If they use respirator A on Monday, for example, they would make sure that next it is the respirator A is used on Friday or Saturday, making sure that the time between the use of the same respirator is more than 72 hours, mainly because in case the surface of the respirator is contaminated, greater than 72 hours basically reduces the viability of the virus. The second process we see is reprocessing and decontamination method, basically which it is a method. Hello. It is a method whereby you have to first make sure, you have to ensure that uh, uh, the respirator is appropriately maintained to make sure you reuse it. The decontamination method has to basically, the problem is we do not have appropriate decontamination methods which will certify that once you decontaminate it, whether really the respirator has been decontaminated or no. And then you have all these other four methods like hydrogen peroxide, vaporization, UV treatment, moist heat, and dry heat. And what CDC normally recommends is, although these are some of the most commonly followed strategies, they are, so far they have been less peer reviewed, or they have not been peer reviewed, and therefore they cannot CDC cannot give a confirmatory statement against these following strategies. And it purely depends on based on your respective the judgment or policies set by your infection and prevention control department along with your local health authorities, and purely your visual observation. And now some of the recommendations for the extended and limited use of N95 respirators is, first of all, as much as you can, make sure you minimize the number of individuals using an N95 respirator. For example, in an healthcare industry, nurses who are not coming, or people who are not coming in direct contact, or people who are not in places where the exposure level is there, or they're not exposed to certain respiratory hazards, may not use an N95 respirator. They can use a surgical mask. The second, what CDC also recommends is alternatives in case and where permissible and where feasible and possible. Try using half face mist, full face mist, and PAPR just to reduce the load on N95 respirators. But again, because they are with valves, they have to be used cautiously and in consultation with your infection and prevention department, your local health authorities as well. Uh, what they normally say is, again, implement practices allowing extended use or limited use of respirators when acceptable. Because what happens is, globally, to be honest with you, there is approximately around 50 million. The demand for N95 respirator per day is approximately around 50 million. And China, being one of the largest producers of N95 respirator, they have a capacity of only 20 million a day, which basically we still have a shortfall of approximately around 30 million. And that is one of the main reasons why the reuse or limited use or extended use strategy has come into play. Then we come into prioritizing use of N95 respirator only for people who are at the highest risk of experiencing complications or infections. And always make sure, if extended use is permitted, ensure strict adherence to engineering and administrative controls, which is the utmost important in all of these. Whenever, what CDC also recommends is, whenever you're reusing respirators, make sure you have appropriate engineering and administrative controls. The whole purpose of having or concentrating mainly on your engineering and administrative controls is mainly because through these controls you can reduce the exposure level, or the level to which your respirator is exposed to the contaminants. And also a very key feature, on the goal over here is based. Hello.
Go on.
Yeah,
Go
also,
on.
a key feature during all these strategies is make sure at any point of time your respirator maintains its fit and functionality. As they say, even assuming your respirator is used 3 times, okay, assuming you have used a particular respirator for 3 times, and you have observed that it has been significantly damaged or soiled, or it has lost its functionality, please discard the respirator before rather than using the same respirator, as it can be a potential respiratory hazard for yourself.
Okay. Hello, Karen.
Yes, doctor.
Yeah. We'll just have to hurry up. We are nearing our time limit, so just a little quick.
Yeah. Okay.
I think would be better.
Conditions under which N95 respirator has to be discarded is first is following, assuming in case you use it during aerosol generating procedures, in case the respirator has been contaminated with blood or respiratory or nasal secretions, in case your respirator becomes damaged or hard to breathe through, in the event of frequent contact with the inner side of your respirator, and or following close contact with any patient who is co-infected with various respiratory illnesses. Now, the goal over here is basically to discard your respirator before it can become a hazard to you yourself. Now, this is just a chart which have been shared by again CDC, which they basically have uh, for the reference of viewers. Airborne particulate hazard present, you have in case it's yes, will the person be working in a setting, a surgical setting, or needs protection against high velocity fluids? Yes, then you need to use a surgical respirator. No, then you can use a particulate respirator. On the other hand, are airborne particulate hazards present? No. Will the person be working in a surgical setting? If yes, he needs to use a surgical or a procedure mask or a medical respirator. No, then a comfort mask. It is important to understand the difference between a surgical mask, N95 respirator, and a surgical respirator. Now, surgical, basically, there are some respiratory protection devices which are certified by the FDA as approved surgical masks, and the same protection devices are also certified by NIOSH N95 as N95 respirators. We call these class of respirators as surgical respirator or medical respirator or healthcare respirators. Particulate respirator basically means it is certified only by NIOSH as a particulate N95 respirator. Okay, now coming to eye protection. Under eye protection, basically we have eye protection is basically divided into two parts. We have spectacles and we have goggles. Spectacles is further divided into spectacles and over the glasses, and we have goggles, which you probably have a set of goggles to protect you. Now, the main difference between a spectacle and a goggle is spectacles will protect you from dust or anything that's coming straight onto your eye, whereas goggles will offer you both two ways protection. One is they will protect you from dust, and they will also protect you from splashes. The main reason spectacle is not effective against splashes because when a splash occurs, you cannot determine the projectile of a drop, and that is one of the main reasons we opt for goggles. Now, for those who are not coming in, again, it, for those who are basically not coming in contact with aerosol generating procedures, or basically who need eye protection but are not at the risk of major eye hazards, they can opt for a spectacle. For those who already have prescription eyewear, they can opt for over the glasses. Often we get this question saying that I want to wear a spectacle but I cannot because I am already having prescription eyewear. Well, for those people, they can opt for over the glasses. But that being said, both this come under the group of spectacles. In goggles, you have, again, you in safety eyewear, you will have basic goggles, basic splash protective goggles, and you will have anti-fog goggles as well. It is very important to understand over here that the choice of one pp will have an effect on the choice of the other pp. For example, in case you're wearing a disposable respirator, you might have to go in for an anti-fog goggle. The main reason is because in a disposable respirator, most of the times you might not get an appropriate fit. Because you don't get an appropriate fit, your eyewear will start fogging. In those cases, you might have to go in for an anti-fog goggle. Now, in case you use a reusable respirator, in case allowed or permitted, then in those cases you can go for a basic splash goggle, because when you use a reusable respirator, the fit factor is much better. That basically drastically reduces the fogging in your eyewear. One of the most important things also,
Karen, yeah, Karen. Yeah, I think we are running over time. Do you have a lot of slides remaining?
Doctor, I'll just take you through it. I don't have much. I just have a few slides, but I'll just quickly take you through.
Sure. Okay. Yeah.
So basically, what CDC also says is when dealing with aerosol generating procedures, make sure you have appropriate respiratory eye protection, and it is always advisable that you use a face shield above for an appropriate level of protection or for better protection. Face shields again are available in reusable and disposable range, but in either ways, whatever is comfortable and whatever is appropriate as per your need, you can go with it. Now coming to body protection, just to make things short, we have body protection, we have different types of full body coveralls, full body gowns, and plastic overalls. One of in body protection, again, one of the most important things to understand is, in case you want an appropriate protection, you have to basically opt for a body coverall, and because body gowns or plastic overalls don't offer you a full body protection. Now when coming to standards, we have basically standards for protective clothing, starting from type 6, type 5, type 4, going on to type 1. Type 1 is the most stringent. They basically, these are gas type suits. Coming on to with respect to with respect to the medical industry, in case what we require is, we need to go in for type 5 and type 6B certified garments, because type 5 and type 6, as you can see, they are certified to protect against solid particulates and limited splashes, but type 5B and type 6B are certified against are also tested for biological barriers. Or you can opt for a type 4 type of a garment. Globally, these are the protection standards which are followed. As you can see, there are, this is just for your reference, different styles which are followed, or different standards which are followed by each continent, just for your reference. Okay, before I go ahead, the last thing I would say is suggestions and recommendations. One of my most important thing, because PPE, especially respiratory or certain PPEs, are not so extensively used in the medical industry, and this is something which is new. First, it is a suggestion to have a dedicated person for PPE management in your team. Like often in the industries, we have safety officers or we have a safety team. In your team, you can opt for a person or a two to basically do, or be in charge of PPs. This same person would then be training the other people, or this person would be responsible for determining the safety or PP policies for your team. Next, we recommend having regular and periodic training for staff and healthcare workers. This is one of the most effective ways, because time in and time again, effective and periodic training basically helps a staff, or basically helps your team to ensure that they adhere to strict requirements.
Hello? Hello?
Feel wear it for long time, so that the goal is to basically try to understand how you would actually feel. You might feel uncomfortable, you might feel, there might be a lot of practical issues which you do not want to face when you're actually into that area. So once you get these things sorted out, you would be in a better position to wear PPs and work in your workplace. Try having posters which would in your workplace, which would determine how do you wear it, simple steps of how to wear, how to discard, how to take off, or certain procedures. As they say, actions speak louder than words, pictures also speak louder than words. Posters with just images, what you can additionally try to do is to make it more relatable to your people or to your team. You can ask them, once you determine a specific set of procedures, you can ask them basically to wear it, and you can click pictures step by step, and those you can then make posters which are more relatable. And what happens is, once your people also feel more accountable, and it is much more understood or understandable by your team. When you look at the entire thing, the most important thing is, you'll have to redesign your engineering and administrative controls to basically reduce your burden on PPs. As I say, at the end of this, you will have to basically go back to the drawing board and see the entire thing not only as a PP alternative, but how can we, if possible, eliminate, if not eliminate, substitute, if not substitute, have appropriate engineering and administrative controls, only to ensure that you reduce your burden on PPs. Hello. Yeah. Also, wherever possible, use alternatives. As CDC also recommends, use alternatives wherever possible. like reusable half PAPRs or any other means, but this should purely be in contention with your infection prevention department and your healthcare wherever possible. The goal is basically to reduce the load which comes onto your PPs. Seventh most important thing is have a feedback, because when you have a feedback, you'd also be able to understand what are the practical issues and then you can dwell upon them. As I say, again, hello, doctor. I would.
Yeah.
Doctor, last thing, as I end, I would just like to show you a slide which we had developed for one of our pharmaceutical industry, which would be relatable to you all.
Now, I think we are overrunning time, Karen. So we will. Hello.
Yeah, doctor.
I think we have overrun by almost 12 minutes now. So we will. Okay. So I thank you for your lecture. Wonderful lecture. There have been some connectivity issues, but it is really an eye-opening lecture regarding how the masks work. Most of us commonly believe that it is the pore size, the filter size, but it's actually the electrostatic charge. And also with respect to categories of suits and stuff like that. Many members have not been able to see, including myself, the demonstration of the fit of how the N95 is to be checked and what's the proper way to wear it. Well, Mr. Karen has been kind enough to offer that he's willing to come and have another lecture whenever possible, come and give a lecture at IMA Tiswari, or give a live demo or an online demo of how these valves are to be used, worn, and what is the best way and how to check the fit and stuff like that. So maybe in the future, we'll definitely consider it, and we thank him for his kind offer. Mr. Karen, thank you a lot. And we have a small token of appreciation for you, which we will reach you in Margao, because Mr. Karen is speaking from Margao. Thank you.
Thank you, doctor.
Okay, yeah. And I'll not take many questions. Just one question one member has asked, which I am also interested in. Can a UV sterilizer be used to sterilize N95 masks? Only one question.
Yeah, so what they say, what CDC is also saying, in case you want to UV, you want to do that kind of a method, you would have to take off the nose clips and any metal belonging on the mask, which will significantly deteriorate the physical property of a mask. And that is one of the main reasons why they have listed UV treatment. But it is, since it has not been peer reviewed or it has not been tested appropriately, they do not consider it as a foolproof or 100% method for ensuring that it can be reused or it's a suitable decontamination method.
Okay. And just another actually very good question, but it can be, if you can answer shortly, just like how N95, there's a list of N95, is there a list of PP suits also, or a website to certify PP suits also?
No, not really. There is no list of PPE suits, but the best way, because again, PPE suits define the medical industry.
No, regarding approval, you said N95 mask approval can be checked. PPE suits can be checked anywhere?
No. You purely have to go as per the certifications which are available.
Sure. I thank you a lot for your questions. Members have a lot of questions, but we cannot take them right now for shortage of time. And one member has requested if you can post the link of the videos of how to fit this in the chat box, that would be good.
I'll do that.
I'll take a 1 minute break to be back, and we'll be back with our next session. Just a minute break. Members can be back in that time. Thank you.